This is our October webinar, Electrification, Don't Drink the Kool-Aid Yet. Our two presenters today, Fredric Goldner from Energy Management and Research Associates and John Avina with Abraxas Energy Consulting. Fredric Goldner is a founding principal of EMRA. Over his career has been involved with a wide variety of projects from research to facility audits and use analysis to energy program design and energy and water efficiency upgrade implementation. Mr. Goldner is a nationally recognized expert in the area of energy auditing and management and has led audits and audit teams for hundreds of facilities totaling tens of millions of square feet. He's also an adjunct professor at the Center for Energy Policy and Research at NYIT. Over the past 35 plus years, Mr. Goldner has taught over 13,000 professionals and trade persons across the globe, in addition to co-authoring a number of publications and books. He has received numerous awards for his work. Most notable of these is when he was inducted into the Energy Managers Hall of Fame for his lifetime of achievement in promoting the practices and principles of energy management. And John Avina, many of you have met John Avina before, and this is our president of Abraxas Energy Consulting. He has worked in energy analysis and utility bill tracking since 1994 during his tenure at Thermal Energy Applications Research Center, Johnson Controls SRC Systems, Silicon Energy, and Abraxas Energy Consulting. He has managed the M&V for large performance contractors, managed software development for energy analysis applications, created energy analysis software that is used by several hundred energy professionals across the globe, over 250 energy management classes, and created hundreds of building models and utility bill tracking databases. He has also modeled hundreds of utility rates and personally performed energy audits and retrocommissioning on over 25 million square feet of building stock. John chairs the Association of Energy Engineers Certified Energy Audit Test Committee, and John has an MS in mechanical engineering from the University of Wisconsin-Madison. So I'm gonna mute myself and let our two presenters take it away. And go ahead, Dick.
It's up to you, Fred. Let's see what you got.
Okay, well, first off, I'm just gonna apologize. I'm a little bit scraggly today. Unfortunately, my mom passed away about 10 days ago, and so this is a Jewish custom for the next month. Anyway, well, thank you everybody for showing up. And what John and I are really trying to do here is recreate a conversation that he and my colleague, our colleagues, Seat Patel and Richie Costello and I had over dinner at AE East conference about 6 months ago, and was very interesting. And so let me just start off by saying that I'm an environmentalist. And the reason I got into this industry and do what I do is that I want to save the world. However, some 35 plus years of boots on the ground experience has taught me that we have to do something that stands a chance of working. Otherwise, policies that just look good and sound good on paper but have no footing in reality can and will do more damage than good. And they stand to keep us as a society, folks, from the opportunity to make a difference while we can still effectively mitigate the impact of our energy use on the climate crisis. Now keep in mind here, as I am probably, I'll speak for you for a second here, John, what some might consider strong or even bold and even non-PC statements, that John and I have no economically vested interest in this subject matter. And our only concern is that we as a society do something to address the environmental issue, health crisis that we all face. Now, before we get into it, I have a quick teaser. 4 feet, 8.5 inches. Does anyone know what the significance of that number is? other than John, obviously, because we discussed it earlier, and let's see who, at least for a little while before a doctor's appointment, is listening in here. You know what? I'll get back to that later, but keep it in the back of your head. So, John, do you mind if I start off with just a little bit of an example of what we're talking about from that I've seen develop here in New
Yeah,
York
let's
City?
hear it.
Okay.
Absolutely.
So, and I'm sure this is in many places around the globe, for that matter. But I'm going to use New York City because I'm most familiar with that, living in this neck of the woods. You know, there are policies and local legislation put forth by politicians, the New York City Council, the mayor's energy office, and now mayor's office of sustainability, for example. And if they had their wish, or if they had their way, better said, every building in New York would have their existing heating systems yanked out and replaced with air-to-air heat pumps. And this is insane on so many levels. You know, first off, there's not enough green electric on the grid. So, you know, at the outset, and I know eventually there will be, and I saw some of the people who logged in here, and Andy, I'm speaking to you, will say, well, it'll happen, right? But in the interim, until we get there, we're actually, and now that they took Indian Point, major nuke plant, just a little bit upstate from the city, offline, you're talking about even a dirtier mix of fuels making that electricity. But now let's move on. Even if there was enough green or clean electricity on the grid and available, there isn't enough capacity in the transmission lines to bring it to the city, or in the streets in the distribution system to get, you know, to get that green electricity to the buildings. And I'll come back to, you know, what the real life issue with that is in a moment. And then even if there were enough, next off, so even if there's enough green electricity in the grids and there was enough capacity in the streets, which were nowhere near the T&D system, the wires feeding these buildings, and here I'm talking about commercial office buildings, retail buildings, and I'm going to default in some of my next few thoughts to apartment buildings. While I've worked on everything from industrial to institutional to A and B class commercial office buildings, I've spent a good, probably the most field time during my career working in multifamily. So I'm going to kind of default a little bit to that, but this applies to all of those building types. You know, so the wires, so where I was going, the wires feeding those apartments or those offices, they can't handle a load. So that would mean ripping open the walls to rewire. I don't know, John, if you've ever been involved or anybody here in a project like that, but there was a 55 building complex built just pre World War II, or actually during World War II, that they had to redo all that wiring for some other reasons. And the project manager who was doing that, John Mulholland, he actually set out guards, security guards on the floors in each couple of buildings that they went through, because people needed to leave the doors open because you need to go from one apartment to the next. You had to work your way up the building, one line, one set of risers at a time. And it was a nightmare. Well, it would have been a nightmare, except John did the most beautiful job I've ever seen anyone do. But it was a monster of an undertaking, and they should have been kissing his feet when they were done. I can't imagine anybody else having gotten through that project, but it's a major thing. Okay, and then so now we don't have enough wiring or capacity in the wires going up in the building. And then even if we did, now you have radiators that need to be ripped out, and we need to punch holes in the walls for the heat pumps, because we're talking air-to-air heat pumps here, right? So now as to those last two items, let's just look at the 120,000 multifamily buildings in New York City as an example. Even if all the technical stuff and economic stuff started to go away, there's the human issue. Ripping apart Mr. Smith or Mrs. Jones' apartment, the apartment that they spent either their own money and or their own efforts to make nice and fit them. If you and fit their style. If you think, or if any of these policymakers think that Mr. Smith and Mr. Jones and all these other folks are going to be happy about having all that stuff ripped apart and that intrusion on their life, well, then you haven't met a New Yorker. Right? And I'm going to say you haven't met a Texan, and you haven't met someone from Minnesota or any other place for that matter, right? I'm going to tell you, they're going to tell you where to go, okay? And it's not going to be a nice place. So then the cost, what is that going to cost? And this is just not going to happen even with what I call OPM. John, do you remember that OPM acronym? Other people's money, grants and utility incentives and government money. So, but even with OPM, other people's money, this is, yes, some buildings it will happen, and it's starting to, but when we're talking about large swaths of building and doing it in every building the way they want to, this just has not been thought through. Now, just so folks don't think, oh, Fred's just a crotchety old cynic. Actually, and Asit and I were talking about this again this morning. I and he and many of us are not against using heat pumps in new buildings where they're part of the design. If it's part of an initial design and the construction is set up for it, then it makes sense. And I'm not against that. But when you're talking about taking square pegs and putting them into not round, but amoeboid shaped holes in existing buildings, it's not going to work, but in a really small part of the population. John, do you have anything at this point? Because I'm tired of hearing my own voice.
It's kind of interesting. So they want to do this for all of New York. Is this a law that they're going to?
No, it's not a law. I mean, they have other laws like Local Law 97, which is, I think they call it the Climate Mitigation Act. I call it, and my clients call it the Carbon Tax Law, and that's essentially really what it is. You get a limit based on the type of building and characteristics, and you get, I think, a certain number of tons per square foot of the building, and then if you go over, it's $268 per ton of carbon emitted each year. And honestly, as an environmentalist, and even as a professional, but certainly as an environmentalist, I have no problem with the carbon tax law. I mean, some of my clients may not be happy to hear it, but I have no problem with that. I'm actually for that, because until you make people feel it economically, the odds are that most of them aren't going to do anything. Yeah. But this is a policy that they're pushing. That, listen, they outlawed number 6 oil, which I think is good. They're outlawing number 4. They're trying to make that happen a little bit sooner than later. They haven't talked about number 2, but they're going to have to eventually. but now you hear, and I have something a little later on in my mental notes that I want to come back to about natural gas. They're kind of pushing in that, getting rid of that as well. They really want everybody to do this. And I think that is where the mistake is.
So right now, then New York City, I don't know if there's any plans on the books, or not on the books, but plans that are written, but this is the debate that's maybe happening here and there. That, should we make a new program like Local Law 87 or heat pumps to get rid of the other kind of heating?
Yeah, and you see that's what they're advocating. And if you talk to the folks who have, the Beltway Bandits, I forget which one is holding the main contract to run a group here in New York with, again, younger people without a lot of real world experience. And you talk to them, and some of the consultants, some of the energy consultants and engineering consultants have essentially drunk the Kool-Aid, and I've been asked to come in and do Local Law 97 advising for clients who, the last engineer that was here, the energy service company, they gave us a proposal to put in air heat pumps and all the things. They said that's what we had to do. And so they're pushing with their own voices, the city officials, and they're pushing with their, paid consultants, and they're pushing the private consultants like you and I, like Abraxas and Energy Management and Research Associates and others to advocate for that. And now let me say that using heat pumps in conjunction with geothermal or earth coupled systems where the resource access is available, typically you wouldn't think of Manhattan there, even though, like, who was it? St. Patrick's Cathedral, which everybody knows, they put in a system, but the economics of it, I guess for their case, thank God that the church is like the richest organization on the globe, and they put it in, and I think it's a good thing that they put it in, but nobody else could have afforded that, honestly. But I think where the resource access is available, it makes sense. And in fact, I believe, and I've always been against using electricity for heating because it's the highest form of energy. Listen, there's certain things you cannot do without electricity. What we're doing now are refrigerators. I know they're propane refrigerators, but for the most part, refrigerators, TVs, phones, right? You need electricity. Heating is the lowest form of energy use. You could do it. I mean, hell, you could take these papers I have on my desk here, right? And just light them on up there and you can get heat from it. So I've always felt that heating with electricity is a crime against society. The one place where I kind of always felt it was okay was with geothermal, because you're using that relatively unlimited resource in the ground as a heat source and a heat dump. I will say that my thinking is changing a little bit more with climate change in the last 5 or 10 years, that if we can get green electricity, it starts to make a little bit more sense in more places. But when I come back to geothermal, this could and probably should be a big piece of our low carbon future.
But not in New York City.
Well, I mean, maybe in the boroughs, not in Manhattan. And now you just said a very Manhattan-centric thing there, John. People, and even around here, think of Manhattan as being New York City. But I mean, I grew up 3 blocks from the ocean. Where I grew up, they could certainly do it because there's a lot of green spaces around the buildings, and you could tap that type of a resource, as are there in other parts of the city.
Fred, so we have a comment from Catherine. and she was willing to join the conversation if you guys would like.
Yeah, please.
Excellent, please.
Catherine's great, always.
I will unmute you, Catherine.
Hi guys, how are you?
Hey.
Hey
Hello,
Fred, I
Catherine.
think you look good. You know, people like yourself, Fred, and that really take a look at an individual institution, and each facility is completely different. It is a different scenario when you're looking at new, but depending on the type of customer and how energy dense a customer is, and the constant use of energy, and then whether or not you need backup at a facility, really comes to the different slew of solutions that you can utilize. But to me, when we have this discussion, I think it's really important not to be as negative as you might have been, Fred, but to sort of turn it around with, all right, guys, what is the goal? The goal isn't necessarily electrification. The goal is to decarbonize, to do a deep carbon reduction. That is the goal. That's the goal I've understood. And just relying on, and you illustrated many of the difficulties relying on just electrification as a pathway, in my mind, is actually going to put us behind in being able to achieve the targets that we need to achieve. So I think it's very important that engineers, people with technical backgrounds, be part of policy discussions, and in a very polite but persistent way, educate. Okay, it's very important to educate, because the thing is that a lot of people who have deep commitments to see our environment get better, that to reverse climate change as best we can, are not as educated as we may be as to what the possibilities are. And our job is to educate those folks that there are other possibilities, and it may stretch your patience, but I think it's very important to do this. And two, it's also important to be armed with facts, to have those case studies. Say, hey, for this type of building, I can do this, and I can achieve X, Y, and G savings, and make that part of that policy discussion. Because without those facts being introduced, what policies being changed and enacted in legislation as a result of a lot of well-meaning folks thinking electrification is the answer. So, we need to get involved, and we need to be armed with facts, and we need to be patient.
And thank you, Catherine. I think Catherine makes a great point, is that folks, some of these policy folks have forgotten what the end goal is. That they see the shiny object, right, out there, and right now they're focused on that. And I think, Catherine, that really was the point of our discussion 6 months ago, and what John and I wanted to go over here is, look, let's keep our eye on the bigger picture. And some of my mental notes that I made for myself, I have that later on. Where could we be going as that mix? I'm actually, I'm just going to jump around in what I was going to say. I'll make reference to Energy Future, a book that I read many years ago, and I'll come back to that. Let me just throw a couple more facts out there, picking up on what you said, Catherine, is getting back to the T&D system. A study by London Economics International suggested that it's going to require some 37 billion with a B, 37 billion in incremental T&D investment to get the grid capable of handling that building electrification load. And that's in addition to a number not too dissimilar for the additional generation infrastructure.
That's in England, though. That's in the UK, correct? They weren't studying.
No. That's for New York City.
That was for New York City. They were studying.
Yeah, someone in a group in New York hired them to do that study for the New York market or for the Con Edison grid. So 37 billion just in New York City alone. Now, you talked about case studies, Catherine. Let's look at the real world example of, forget a whole building heating system, but just DHW, domestic hot water, electrically driven heat pumps or electric driven heat pumps to make just domestic hot water, which is a smaller part of the thermal load in an 80 unit building. And this is not theoretical. This is some demonstration projects that C. Patello I mentioned before is doing to replace the DHW system in this building with a conventional, like a gas-fired one, would cost somewhere between 50 and 100,000, roughly. In this case, they happen to have a courtyard to put it in, which is atypical for most New York City buildings. Anybody want to take a guess? And John, I think we've discussed this, so you know, what the cost of putting in the heat pump, electrically driven air-to-air heat pump system? Anybody, you can put it in the chat box or.
I have no idea. I'd like to hear that and the payback as well.
Okay, well, you're not going to bother to calculate a payback when I tell you a number. Would you believe somewhere between a little north of $700,000, between $700,000 and $800,000 compared to the 50 to 100. Now, I'm not saying that not doing this isn't important because it gets rid of a fossil fuel, but there's another building where it a 200. So first, let me say before I go to 250 unit building, another 80 unit building that what this one has, and that's not an estimated cost. That's an actual contractor cost. It's a project that's happening right now.
And how many people were in that building?
80 apartments. So for New York, not a small building, you know, a
like
moderate.
10,000 per apartment, more or less. Okay.
And then where they're going to have to put it up on the roof, this one hasn't gone to construction yet. But there isn't, the elevator isn't big enough to get it in the equipment in there. So they're going to have to hoist it up, and then they're going to have to put dunnage, you know, structural up on the roof. They're looking in the vicinity of 800 to 900K, and then a 250 unit building where it's also in the courtyard project that's going on right now, $3 million. So I ask you, what owner is going to pay for this or even be able to afford it? Now, you mentioned, John, a moment ago, there's a lot of public money, you know, in the last stuff that went through Congress, and I know NYSERDA's throwing it out there. I assume CEC in California and lots of other places. I know Massachusetts is throwing lots of money at this too, but for those technologies, but not that level. I mean, you'd be talking about trillions and trillions of dollars to start putting this in all the building. And then what about the cost of those green electricity? You know, just FYI, I did my master's thesis on photovoltaics, and I'm a big supporter of wind and solar. Yeah, the electricity source is free, the sun and the wind, but the folks who build those generators, the wind and solar farms, they aren't billionaires who are in it for the feel good. They need to recoup and then get a return on their investment. Then let's throw those transmission lines aren't free. Do you think Con Edison and the other local distribution companies, the other utilities, don't need to recoup that $37 billion for the distribution upgrades?
So,
you know?
Let me jump in there. So I don't know about the transmission lines, but I'm sure that Inflation Reduction Act that they passed is going to put a lot of money into the transmission and distribution. I don't know. I haven't found that, but I wanted to mention what I did look up. So this is just for residential. It's not for multifamily, but there's a lot of money that's being thrown at this, and it's not just at the heat pumps, but it's also on redoing your wiring and putting in new electric service, or changing your panel and all. For example, they'll pay for, so there's tax credits and then there's incentives. The incentives are going to be done through the states, so it hasn't really been worked out yet. It takes a long time for government to figure out how to do whatever they're going to do and make programs. But the federal tax incentives, I think that's already figured out, and they're going to pay 30%. They're going to give you a 30% tax credit. I'm sorry, not tax incentive, tax credit. They're going to give you a 30% tax credit up to $2,000. This is for homeowners for heat pumps, but they'll also give you up to $600 in tax credits for changing your home electric supply so you can power a heat pump. That's that part. But the rebate part or incentives, it's up to, I don't know, $8,000 to $10,000 per home for putting in heat pumps. And if you are in a low enough income, it means 80% below median income. So you can get, it'll almost pay for the entire heat pump itself. So this is for homes. This isn't commercial. I don't know what commercial.
Right. No, and I think that's good. And in a home, hopefully, you're not going to have to rip out his walls and, and so, like I said, I'm not dead set against this. What I'm focused on, and thank you again, Catherine, for bringing this up, is that we need to keep our focus on what the real goal is here and not be attracted to this shiny object of, just blind electrification. Because even the demonstration heat pump systems that are going in the next few years with equipment paid for by that OPM, other people's money, there's going to be what I would suggest is beyond sticker shock of operating those systems, the energy or the electric bill cost. Does anyone even want to take a wag of what the cost of running these systems can be once all of those additional costs are going to be? You think 20 cents a kilowatt hour is expensive now. Just wait. And then, and I wish Asit was here so he could tell some of these stories himself. But before he started doing these demonstration projects, he and a bunch of his colleagues went up to the manufacturer of one of these heat pump systems, one of the really good ones, up in Massachusetts. And the engineer there, when I said, well, what about the cost of operating the system? And the engineer goes, oh, that's a wash, right? And
they're not paying for gas anymore.
Because he thought it was, he thought it was a wash because the only project they'd done like this to that point was in the state of Washington, where they were changing electric resistance to the electric heat pump. And so when I said, no, demand, even if the energy unit cost, for kilowatt hours versus therms and natural gas was equal, and I don't think they are, but let's assume for a second that they are. The demand cost, because this was a 7-unit modular system, but unlike with boilers, we can bring them on one at a time, just the basic design of these heat pumps, the whole 7, or at least 6 of the 7 need to come on at once. So you're talking about a $1,200 monthly demand cost. Now for an 80-unit building times 12 months, that's a nice chunk of change. And I guarantee you the owner of that building, not a happy camper. And then at the beginning of this, there's a particular, there's a few engineering firms, but there's a particular one that had the ear, or was a darling of the mayor's office of sustainability. And they were out there and they come to our New York AE chapter meetings, and talk about how this is the greatest thing since sliced bread. And now you see them kind of backing off. I'll come back to that in a moment. But they said, oh, one of the talks, oh, you'll get free air conditioning in the basement.
Oh, yeah.
John, you got the master's in mechanical engineering. That's not well thought through. And the one of the guys from the manufacturer says, no, you can't. That's not true. You can't do that because the pipes will freeze. And then he goes to his seat. Ask me how I know the pipes are going to freeze.
Yeah.
And so I asked him what, because that happened right here in our test facility. So again, people not thinking through the whole thing. John, I have something else, but I'm going to take a different tangent here, so I'll just throw it out there to you.
Tell me, why would the pipes freeze?
Because you take so much heat out of the space to put it into the refrigerant.
That cold down there in the basement.
It gets that cold.
Got it.
Right?
Yeah.
So you literally can't do them inside. You have to put that part of the heat exchanger, that part of the refrigerant cycle outside, in the environment, right?
Yeah.
And speaking about in the environment, blackouts. It's one thing to have blackouts in the summer when you're using these vapor compression cycles
right.
to overcome a 20 to 30 degree delta T. But what happens when if you have a blackout? Listen, the world, people for our existence of humankind has dealt with that 20 to 30 degree delta T. So you're a little hot, uncomfortable. Obviously, for older people, that is a health and safety issue. But for the system, it happens, blackouts in the summer. But what happens when you have a blackout in the middle of the winter? And now and you're up in a northern climate and you've got a 50 to 70 plus degree delta T. Now you've got a real health and safety, and I think it's more than just a health and safety problem. You got a real, issue.
Yeah, your pipes are going to freeze again. They're going to break.
And then speaking of pipes, refrigerant leaks. This is where I saw that a firm whose name I'll keep to myself at the moment. Every year they showed up, or every year and a half they showed up to a chapter meeting, and they talked about these air heat pumps being the best thing, greatest thing since sliced bread, and everybody was going to have them, and it's going to make sense. And then you see them to backpedal. And one of the things they started to backpedal on is they started to admit each time a little bit more about the refrigerant leaks. And now, if you're having refrigerant leaks in demonstration projects where you have, I will say, one of the really high level, better engineering firms and energy firms with their eyes on it as they're designing it, as it's going out to bid, as it's getting built. And then you have the funding, the state or the government funding agency having their eyes on it, and you select the best plumbers and contractors. If you're having leaks in those kind of situations,
Right.
what happens when Jim or Larry or Lisa or Nina, building owner or board, goes out and they put this out to bid and they hire Joe Schmo plumber on the lowest bid? If you're getting these kind of leaks where everybody's eyes are on it, what happens when nobody is watching? Honestly, and a seat in his own home had one of these systems put in. So we're believers, in doing trying to do the right thing. And his system was put in by folks that he knows that do top-notch work. And maybe it's an anomaly, but it in fact happened in the last 4 or 5 years since it went in. 3 leaks in 4 or 5 years. That's what R410A with a greenhouse warming potential, GWP, of over 2,000. And I have other stories about this with contractors. Those things come in lengths. The refrigerant piping, if you're doing a VRF system, comes in lengths of 75 or 100 feet. So they watch it go up next to a nonprofit client of mine, and the weatherization director. So some people here know who I'm talking about. Watch them construct this, and you're supposed to only use, the factory made lengths of that refrigerant piping. But what does a contractor do? They use a piece that's 75 foot long. They have a 25-foot piece left. They use another piece that's 60 feet long. They have 40 feet left. They use another piece that's 90 feet long. They have another 10 piece left. They now have to go 80 feet. What are they going to do? They're going to take that 40 and that 25 and that 10 and another 5, and they patch them together. Why? Because contractors have to make use of every piece of resource they have. They can't afford to not use the materials they got. They have to make a profit at the end of the day. And every one of those joints, that's asking for a leak, right? So and I'm going to be a little cavalier here, but in the end, the environment might be better off converting all buildings back to number 6 bunker oil. I mean, not that I'm really suggesting that, but yes, and I know, and I hear Andy in my head here. Oh, yeah, but the CO2 refrigerants, that's got a GWP of 1. Well, there's not that many systems out there, and so it's not quite a proven technology. And when it is, maybe we should consider it more. But contractors are having real issues with doing that, because instead of a 400 PSI, say on an R410A or a conventional refrigerant that has to be a 400 PSI, the CO2 ones are at 2000 PSI. That becomes a real safety issue, both for the installer and then after the fact if you get a leak, right?
We're at 47 after, so.
Okay, well, I have a couple of other things, if I might.
I want to hear your last points.
When we talk about politicians and bureaucrats, and I'm not talking about the right or left, honestly, most of them do this, wherever side they're on. I do think that some of them want to do the right thing. They've just chosen the wrong advisors to listen to, the ones that have the vested interest, or BYTs, bright young things, kids with Harvard or Yale or Columbia degrees who read something in a book once. But they have a bad habit of setting policies whose impacts can't be measured until after they are long gone. And then some of them even head out of Dodge before the blowback occurs. What I really would like to see is, it's nice to plan for the future, but let's go ahead and do something, do what we can now. 15, 20 years ago, someone from the mayor's office came to the New York AE chapter and asked us all this, and we met with them a number of times. And then a few years later, there are things like the self-inspection on boilers here in New York City. It says you have to do a combustion test. And I said, just enforce that law, make people get to 80%, and you can get to 85, but even 80% combustion efficiency on every boiler in this city today and next year and the year after. It wouldn't have solved this climate crisis, but you know what? It would have helped mitigate a part of it, and maybe we wouldn't be in such a dire situation now, and it would have bought us some time. And then let's talk about natural gas. Our past governor, before his demise, and I think the new one is similar, was like Frankenstein's monster with gas bad, like fire bad. Now, seriously though, not to recognize that gas is an important transition fuel is foolish. First off, New York City pushed Con Edison here to invest countless, probably millions and millions, tens of millions of dollars on the gas system expansion. And Catherine, I know you and I have discussed this, the stranded resource issue there. I think it all comes down to what a book I read back on the shelf here, circa 1980s, book I picked up on my own and then subsequently had to read a couple of graduate courses. Energy Future by Stubber and Jurgen, out of the Harvard Business School. They said that the answer always needs to be a mix of resources, and that mix is going to be different depending on if you're in New York, where I'm sitting, California, where John typically is, Rhode Island, Massachusetts, Texas, Arkansas, Wisconsin, Canada, England, Germany, wherever you are on the globe. But despite their desire for an easy answer, politicians and policymakers and bureaucrats must be made to realize that there is no silver bullet, no single thing that will be a one-size-fits-all answer for the solution to this climate crisis. No single technology, i.e. heat pumps, no energy source or delivery technology or electrification. And to believe so, as they apparently do, is naive and childlike. Where do I think some of the answers are going to be coming? And I am not the expert on this, but hydrogen. Any of the things I mentioned at this point are a piece of the mix. I think hydrogen has the opportunity to be a big piece that I missed, more in some places, less in others. Look, we had 54% hydrogen in New York and Boston natural gas systems back in the 1950s. Now, it came from coal, so we need clean hydrogen in there. Hawaii Gas has 15% hydrogen right now. How much can you put in the system? NYSERDA has a project with the Brookhaven National Laboratory, another consultant, where they're putting 100% hydrogen into existing gas piping, and it works fine, excellent results. There's a demonstration project going on right now here in Point Lookout on Long Island, not too far, about 20 minutes from where I'm at, where they're doing wind to electrolysis. The wind turbines have been there for quite some time, but now they're putting into electrolysis, putting 3% hydrogen into that system for 844 homes. That starts this year. And by 2035, that'll be 10%. There's lots of hydrogen blending projects currently going on in the UK and Germany and Australia. I'm doing some pro bono consulting for a colleague down in Australia, 2 towns over. They're putting 7% hydrogen as we speak into the gas system. Japan, Netherlands. I have a map here that I had in my notes that I printed out earlier, all over the United States, and looks about half a dozen states, British Columbia, Alberta, Ontario, Quebec. And it works in GTI, Gas Technology Institute, was one of my speakers at the last AE World Conference on a session on hydrogen, and it works up to, I think, 30% mix in existing combustion appliances. Geothermal, I think, is big. And the last one I'll throw out there, restoration of reforestation. That's the world's most effective solution to climate change available today. Is the potential to capture 2/3 of man-made carbon emissions. And it finds a landmark. There was a landmark study done by Crowther Lab and published in a peer-reviewed journal of science. John, do I have a chance to finish with the
I want to jump in there on the reforestation. That book I mentioned in the very beginning, Superabundance, mentioned that we actually have less arable farmland now than we had, maybe 40 years ago, and there is more forest cover now than there were 40 years ago. It's like the size of Iowa, or maybe several Iowas, of extra forests in this country or in this world. That's happened over the last 40 years. But yeah, you're right.
But that study identified specific places around the globe, and there were like 6 countries that had the major opportunity to increase their forest canopy, and United States was at number 2 or 3 on the list, and there's a few other countries as well. Unfortunately, Russia is the number one there. But do I have time to finish with that 4 feet 8.5 inches?
Oh, yeah, that's right.
Okay. Okay. So now I'd like to revisit a teaser that we began with. You think that not paying attention to real world details don't matter. Then let's take a look at space travel. In his famous speech in 1962, President Kennedy, JFK, put forth a challenge of getting to the moon, something I'd say that at the time was not dissimilar than overcoming climate crisis we now face. So what's that 4 feet 8.5 inches, you ask? Well, that is the US standard railroad gauge, distance between the rails, 4 feet 8.5 inches. That's an exceedingly odd number. Why was that gauge used? Well, because that's the way they built them in England, and the English engineers designed the first US railroads. Why did England build them that way? Because the first rail lines were built by the same people who built the wagon trains, and that's the gauge they used. Why did they use that gauge? You ask? Because people who built the tramways used the same jigs and tools that they had used to build wagons, which had that same wheel spacing. And why did the wagons have that particular odd wheel spacing? Well, if they tried to use any other spacing, the wagon wheels would break more often on some of the old long distance roads in England. You see, that's the spacing of the wheel ruts. So who built those old rutted roads? Imperial Rome. And I want to thank Dan Holohan for alerting me to all this. But Imperial Rome built the first long distance roads in England, in Europe, including England, for the legions, and those roads have been used ever since. And what about those ruts in those roads? Well, the Roman war chariots formed the initial ruts, which everyone else had to match or run the risk of destroying their wagon wheels. So since the chariots were made for Imperial Rome, they were all alike in the matter of wheel spacing. Therefore, the US standard rail gauge of 4 feet 8.5 inches is derived from the original specifications of the Imperial Roman war chariot. And those chariots were made just wide enough to accommodate the rear ends of 2 war horses, or 2 horses' asses. So, okay, you ask, what does this have to do with President Kennedy's challenge? Well, you see a space shuttle sitting on its launch pad. There are those two orange booster rockets on the sides. Those solid rocket boosters, or SRBs, as they're called, are made by a factory in Utah. The engineers who designed the SRBs would have preferred to make them a bit fatter, but they had to be shipped by a train from a factory to the launch site. The railroad line from the factory happens to run through a tunnel in the mountains, and the SRBs had to fit through that tunnel. And the tunnel is slightly wider than the railroad track, and as you know, that's about as wide as 2 horses' asses. So a major space travel design feature of what is arguably the world's most advanced transportation system was determined by a real world parameter that's over 2,000 years old. So I would suggest that one of our greatest accomplishments, getting man to the moon, is still tied to the real world issue of the width of 2 horses' asses. And if anyone here thinks that they can solve the climate crisis, or anybody in government thinks they can solve the climate crisis while ignoring the real world issues of existing systems, then they are the horses' asses. Now, my daughter said I had to end this on a little bit more positive note, so I'll say the big picture here is that climate change is real, and we can't afford to spend too much of our limited time and resources, or the public's trust and attention span, because that's a real thing there, going down a path that is ill-conceived by folks who may be well-meaning, but lack or aren't willing to listen to those with the dirt under their fingernails experience to make things work. I'll end my comments by challenging those policy folks to get out of their comfort zone or routine and take the time to earnestly engage with those professionals who work in the trenches, not the lobbyist, nor the Beltway bandit crowd they usually hire, and utilize our real world knowledge to help shape their policies and programs so we can all, in fact, affect our looming climate crisis. And with that, John, I'll turn it back over to you.
Thanks, Fred. That was good.
Thank you, John, for inviting me, and thank everybody who's here for your time and attention.